Okay, so welcome back. I hope you were able to find some interesting jobs that use different branches of chemistry. But okay, we're going to go ahead and move on a little bit. And so we're going to start talking about specifics in chemistry. So I want to talk about matter for a minute. Now, I'm hoping that at some point, maybe in elementary school or middle school, you have heard of this definition before. So matter is anything that has mass and takes up space. Okay, so hopefully you've heard that definition before. So, matter is anything that has mass and takes up space. So something like your desk that you're sitting at, or your computer, or your headphones that you've got plugged in, they've all got matter. I mean, they're all made of matter. They all have a mass, and they all take up space. But what about air? If you think about it like that, that's a good question, because does air actually have mass? I mean, yeah, air takes up space because it fills a room. But does air have mass? Yes, it does. So because air is made up of elements, oxygen, nitrogen, a bunch of different gases, and those are made up of atoms, and atoms do have a mass. So that means that it does fit both of those requirements. It has mass, and it takes up space. So yes, air has matter. Now let's talk about mass for just a minute. So mass is how much matter is in an object. So mass is going to be a numerical value because it says right here, it says how much, okay? So that's going to be a numeric value. Before it was just some different parameters that you would have to meet. You've got to have mass and you've got to take up space to be considered matter. This, we're kind of getting to more specifics. The mass is how much matter is there. So that's going to be a numerical value. You normally measure that in grams when you go up to a scale, those kind of things. So we normally measure mass in grams or kilograms. Now, I want to, give you a scenario, because when you walk up to a scale, you don't walk up to a scale and say that you're massing yourself. That sounds weird, okay? When you walk up to a scale, you say that you're weighing yourself. So let's talk about the difference between mass and weight. And then I'll give you an example of what I mean. So weight is mass with the effect of gravity. Okay, so when you walk up to a scale and you say that you're weighing yourself, gravity is acting you on all times. So that's the reason why when you say that you're weighing yourself, that's actually correct, because on the scale you have gravity acting on you, on your mass. So on the scale, when you say you're weighing yourself, it is your mass and the effect of gravity. So let me give you an example of what I'm talking about. So let's say here's the Earth, and here is the moon. Now, just for the sake of, so you can understand me a little bit better, gravity on the Earth is about 10, I'm going to give some units, 10 meters per second squared. Okay, so the units aren't important, but gravity is about 10 on the Earth. Now, gravity on the moon is about 3. Okay. Now the reason why that is the Earth weighs a whole lot more. It's much bigger, so gravity is stronger. The moon doesn't weigh as much, so gravity is not as strong, but we'll come into that in just a minute. Okay. So let's say that you were able to get to the moon. Okay. You're born on the Earth. You've always been on the Earth. Well, let's say that you were able to get to the moon. Your mass in and of itself is 100 kilograms. Let's just say that it is, okay? For the sake of this demonstration, this little picture that I'm drawing here, let's just say that your mass is 100 kilograms, okay? Now, when you go on Earth, your mass is 100 kilograms. But when you go to the moon, your mass is always 100 kilograms. It's also 100 kilograms. Now, remember I said its mass is just how much matter is in an object. So your mass doesn't change between the Earth and the moon. However, when you talk about your weight on the Earth, if you include gravity, It's going to be around 1,000. That's newtons. That's not an important unit. But anyway, your weight on the Earth is going to be about 1,000. It's not in pounds. It's in a scientific unit called newtons. But your weight on the moon is going to be more like 300. Okay, so, if somebody ever asks you your weight, you could just ever so slightly just give them your weight on the moon because it is less. Nobody's going to know. But anyway, so you would weigh less on the moon because it has less gravity, because the weight is always mass and gravity together. Now, your mass always stays the same. It doesn't matter where you are. If you're on the Earth or on the moon, it doesn't matter what the effect of gravity is. It doesn't matter. It's always going to stay the same. Now, if you ate a Twinkie and gained 3 pounds, then yes, of course, your mass is going to change. What I'm getting at is gravity doesn't change mass. Okay, so mass and gravity together is weight. All right, so I'm going to go on to the next page. We're going to talk a little bit about... well, you know what? Let's do this real quick. I forgot I need to talk about intensive and extensive properties. So let's talk about that real quick. So we're going to get into a little bit of talking about different properties of matter. So I'm going to talk about intensive properties and extensive properties. Okay, so they are opposites of each other, intensive and extensive properties. So an intensive property depends... Oh, excuse me, this is the wrong one. I got them flipped. So an intensive property does not depend on the amount of matter. So it's a property that does not depend on the amount of matter. An extensive does depend on the amount of matter. Oh, forgot a word. Depend on the amount of matter. Okay, so let me give you some examples. Let me change colors real quick. So an intensive property example, so that's going to be something, it doesn't matter how much you've got. The property never changes, okay? So an example of an intensive property would be something like color, okay? For example, milk, okay? Milk is always white. Yeah, if you add quick to it, that's quick, whatever it is. Yeah, sure, that's going to change the color. It's not what I'm talking about. Milk is always white, okay? It doesn't matter if you've got a drop of milk that you spilt out of your bowl of cereal, or you've got a whole gallon of milk. Milk is white, okay? It doesn't change depending on how much you have. The color doesn't change. That specific property of color does not change if you have a different amount, okay? So another example of this would be boiling point. Okay, you could talk about a cup of water versus a swimming pool of water. The boiling point of water is always 100 degrees Celsius or 212 degrees Fahrenheit. So that cup of water is going to boil at 100 degrees Celsius. The swimming pool is going to boil at 100 degrees Celsius. It doesn't matter how much you have. The boiling point stays the same always. Okay, but on the other side, the extensive property, it does depend on how much is there. So that's going to be something like mass. Okay, if you talk about the cup of water versus the swimming pool, that cup of water, the mass of that cup of water is going to be little versus the mass of the swimming pool. That does depend on how much is there. Okay, so that's an extensive property. Another one would be volume or length. Things like that. That changes based on how much is there. All right, so 2 more things we got to cover before we're done for today. So I want to talk about properties. Okay, so we've got physical properties We talked about intensive and extensive properties, but now we're going to talk about physical and chemical properties. All right. So I'm going to go ahead and give you an official definition for both of these. A physical property is something that can be observed without changing it. Okay? So a chemical property is going to be kind of the opposite. It cannot be observed without changing it. Okay? So again, this can be observed without changing it. This cannot be observed without changing it. So let me give you some examples. So an example of a physical property is going to be color. Okay, yes, we talked about color a little bit ago, but now we're talking about, is it a physical property or a chemical property of a substance? So color, you can see that something is blue, or you can see that something is green, or whatever it may be, but you don't have to change anything to see that what the color is. You can just look at it and you can see. Another one that you can, that is a physical property would be density. Okay, so density is going to be, how much matter per volume. So that's going to be like if you had a feather that's really, really light versus like a fishing weight, which is going to be really heavy. That's very dense. The density of a fishing weight is really heavy, really, really dense. So the difference in density there. Okay. So that would be an example of a physical property because you can pick it up and weigh it with your hands. You can see the density with your hands by picking it up, but you didn't change anything when you did that. So you were able to figure out that property not by changing it. So another one could be temperature. Okay, you would stick a thermometer in a cup and you could see what the temperature of that substance is. Without changing anything. You would just put a thermometer in there. That didn't change anything. Okay, so let's go over to chemical. So chemical, you've actually got to change it to see that it is a chemical property. So this is going to be something like flammability. So can it light on fire? So we're talking about gasoline. Well, the only way to know if something is flammable is literally to light it on fire. But once you do that, once you do light something on fire, you've changed it. It's turned into something new. Another example of a chemical property would be toxicity. Okay, you can't tell if something is toxic unless somebody ingests it or somebody breathes it in or something like that. So you can't tell if something's toxic until it. Another one that is a good example of a chemical property is reactivity. Now, not all chemicals react. Okay, like if you put sugar and salt together in the same like little dish, they're not going to react, okay? But you wouldn't know that until you tried it. So you've actually had to change something to do that. So you would not know that something is reactive until you tried it. If you ever put baking soda and vinegar together, you know that that's reactive. But when you put them together to test if they were reactive, you had to change it when you did that. Okay. All right, so the next thing I want to talk about is going to be I'm going to go to the next page because this one takes a little bit of room. So I'm going to talk about changes. And so this is the last thing we're going to talk about today is changes. So again, we've got physical and chemical. All right, so I'm going to give you like an official definition, and then I'm going to give you some like cheat sheet ways, easy ways to know if it's physical or chemical changes. Because this on your test, when we do have an exam, physical chemical changes are going to be more important than properties. So I need to make sure that you get physical and chemical changes for sure. Okay, so the official definition for physical change is a change of appearance or phase, not the identity. Okay, so phase change, so appearance is going to be what it looks like. Phase change is going to be, does it melt, like it went from a solid to a liquid, or liquid to a gas, or liquid to solid, whatever it is, that's a phase change, because phases are solid, liquid, gas. So a phase change is technically a physical property, a physical change, because it didn't change anything. It didn't actually like change the identity. Okay, so I'll give you an example of this just in a minute. Let me give you the official definition for chemical change. So a chemical change, a change that causes a substance to change into something new. All right, so whenever you do a chemical change, you are going to make something new. So here are some examples. So if you crumple a piece of paper, remember, we're not changing the identity. The identity stays the same. That paper is still paper. All it did was change the shape of that paper. The paper is still paper, okay? But however, if I come over here and I burn paper, that paper is no longer paper. That paper is now ash. So it turned into something new. It literally went from paper and turned into ash, okay? So I literally changed it. So another example, let's talk about phase change for just a second. So phase change, if you've got ice and it melts and it turns into water, the chemical, look at this, the chemical property literally is ice is still H2O, water is still H2O, the identity never changed. So all it is, that's a phase change. It went from solid to liquid. That is a phase change. It didn't change. Water's still water. Ice versus the liquid water, water's still water. It never changed. Okay? So let's do a couple of examples real quick. So if you were to freeze something, so this would be the opposite of going from ice to water. It's going from water to ice. If you were to freeze something, that is going to be physical because water's still water. Now, we talked about burn. Burn makes something new because it creates ash. Now, if I was to use the term evaporate, that should be a familiar term to you. Evaporate is when something goes from a liquid to a gas. Again, that's just phase change. Okay, but what about spoil? Okay, if you think about this, milk, when it spoils, when it goes bad, it gets chunky and it creates this horrible smell. Okay, that is a chemical change. So let me give you the cheat sheet version of this. Okay, so if you have a physical change, it can be undone. Okay, so just like I talked about the crumpling with paper here, okay, that paper is still paper. You can undo that. Yeah, it may have a little wrinkles in it, but the paper's still paper. You can undo it. But on chemical change, it cannot be undone. So you can't unspoil the milk. Okay, you can't unburn a piece of paper. But a couple of other things that I want to talk to you about is how to also know if you have a chemical change. There's a couple of signs that you may see if you have a chemical change. If you see bubbles, like if you're in the lab and you do an experiment and you see bubbles, that means that you had a chemical change. If you were in the lab and you see light, like you create light, like a glow stick, like you break the glow stick, that's a chemical change. It created light. If you have something that it created heat, okay, like the hot hands that you use, that you put in your pockets, you shake it up and it gets warm, keeps your fingers warm, that it created heat. That's a chemical change. And so also it makes a new smell. Okay, so like when we talked about the milk spoiling, it made a new smell. That's a sign that you had a chemical change. Okay, so there's a couple of assignments that I need you to do. They are in Google Classroom. So you can go back and look at these notes if you need to watch the video again, if you need to hear me talk to you about it, but you should have these notes in your notebook so you'll be able to answer those questions. So good luck. If you have any questions or you're unsure about an answer, you can always go to Google Chat and send me a message. I will be available. Good luck.